Having seen how to multiply a row and a column in example 3, we're now ready to learn how to multiply two matrices in general. Before I jump straight into an example, though, let me give you a quick overview of the process. So let's say I have two matrices I want to multiply, and let's call them A and B. So I want to find the product A times B. Let's further assume that they are both 2 by 2 matrices. So the matrix A is a 2 by 2 matrix, and the matrix B is also a 2 by 2 matrix. You'll see why later, but for now, just take it for granted that when I multiply two 2 by 2 matrices, the result is also a 2 by 2 matrix. Okay, so I'm not going to work a specific example right here, so I'm not concerned what the entries are in these matrices that I have here. But what I am going to do is I want to identify the rows of the first matrix and the columns of the second matrix. So in the matrix A, I'm going to go in and highlight the rows, and in matrix B, I'm going to highlight the columns. And let's go ahead and give these names. I'm going to use R1 for the name of the first row and R2 for the name of the second row in the matrix A. In a similar way, I'm going to name the columns of B C1 and C2. Okay, so now to calculate the product, here's what I do. I am going to put numbers here to indicate the rows and columns of the product. Then, let's say I want to calculate this entry here. This is in the first row and the first column of the product. So that means I need to multiply the first row of A with the first column of B. And if I do that, I'm going to get row 1 times column 1. And the process for multiplying this row and column is exactly like what we saw in example 3. Then, moving over in the same row, to calculate the next entry, I'm still in the first row, but the second column. So now I'm still going to use the first row of A, but I'm going to use the second column of B. So that's going to give me row 1 times column 2. Okay, so now I'm going to move down to the second row. To calculate the first entry in the second row, I need to use the second row of A and the first column of B. So when I multiply this, I'm going to get row 2, column 1. And then finally, to get the last entry, I need to multiply row 2 and column 2. And so that's how I'd calculate the product of two 2 by 2 matrices. So let's see how this works in an example. Okay, so in example 4, part A, I have two matrices, A and B, and I want to calculate both products, A times B and B times A. So let's start with A times B. Just like I was saying before, I need to begin by highlighting the rows of A and the columns of B. If this is your first time dealing with matrix multiplication, I strongly suggest that you actually highlight these rows and columns. It'll make this process a lot easier. And really, even if it isn't your first time, I suggest you try it, and I think you'll see that it's a little bit easier to do the calculation when you have these rows and columns highlighted. Okay, so to calculate the first entry of the product, the entry here that I want to calculate is in the first row and first column. So I need to use the first row of A and the first column of B. So when I multiply these, I get I get minus 1 times minus 2, that gives me 2, plus 2 times minus 6, that gives me minus 12. Just to make it clear, what I'm doing is I am multiplying this row and this column, the first row and the first column, and the reason why I'm choosing those is because this entry I'm calculating is in the first row and the first column of the product. Okay, so let me clean this up a little bit. To get the next entry, I'm still in the first row, but I now move over to the second column, so I'm going to use the first row of A, but the second column of B. And I'm going to get minus 1 times 3, which is minus 3, plus 2 times 3, which is 6. Okay, so now I can move on to the second row. So I'm now going to use the second row of A and the first column of B. And this gives me minus 8, minus 30. And then finally, to get the last entry, that's the last entry is in the second row, second column. So I use the second row and the second column, and I multiply them together. 4 times 3 is 12, plus 5 times 3 is 15. Okay, so now I just add these entries together. I add everything together to get the final result, and I get minus 10, 3, minus 38, and 27. Okay. So let's go through another example carefully, and then I'll start to speed up a little bit as I go through later examples. In the next example, I want to calculate B times A, but using the same matrices. Now that might seem like a strange thing to do because you know that multiplying ordinary numbers, it doesn't matter what order you multiply them in. 2 times 3 is the same thing as 3 times 2. The reason for that is because multiplication of real numbers is commutative. That's the property that states that it doesn't matter what order you do the multiplication in. It turns out, however, that multiplication of matrices is not commutative. The order does matter. And we will see that by working through this example. And you'll see that we actually get a different result by doing the multiplication in a different order. Okay, so going across the first row, I'm going to use minus 2, 3 all the way across. But then I still need to use the first column and then the second column of this second matrix. Okay, to calculate the first entry, I use minus 2 times minus 1 plus 3 times 4. Okay, so now I'm still using the first row, but, let me fix that. I'm still using the first row, but I'm now using the second column. And so that's going to give me minus 4 plus 15. Okay. Then I'm going to move down to the second row. So I use the second row of this first matrix, and I'm going to use the first column. This is going to give me 6 plus 12. And then finally, I use second row, second column, which will give me minus 12 plus 15. And then I do the final calculations here to get 14, 11, 18, and 3. So you can see that this is in fact a different matrix from what we got before. So the matrix A times B is different from the matrix B times A. Okay? So now let's see what happens when we multiply matrices of different sizes. It turns out that we can, in fact, do this on occasion. It depends on the matrices. But in general, the rule to see if you can multiply two matrices works like this. Okay, so the first matrix here is a 2 by 2 matrix. So I need to write its size. It's 2 by 2 because it has 2 rows and 2 columns. Okay. The next matrix, however, has 2 rows, but it has 3 columns. So this is going to be a 2 by 3 matrix. So I'm going to write the sizes of the matrices here. Then, to see if I can actually do the multiplication, what I need to do is make sure that the middle two numbers match, that they are the same. In this case, they are 2 and 2. Those do match, so I can do the multiplication. And the size of the resulting matrix is given by the 2 leftover numbers. So the resulting matrix here is going to be 2 by 3. Okay? So just like before, and I'll explain why, you'll see in a second why that process has to work the way that it does. But for now, just take it for granted that this is the rule for determining when I can multiply two matrices. So just like before, I'm going to identify the rows of the first matrix. The rows of the first matrix and the columns of the second matrix. Okay. So this first entry I'm going to calculate is in the first row and the first column. So that means I need to use 2, 8 and multiply it by the matrix 1, 3. the vector 1, 3, or the column, let's say. So if I do that, I'm going to get 2 times 1 plus 3 times 8. Okay. So now I am still in the first row, but I move over to the second column. Doing this multiplication, I'm going to get 8 minus 8. Okay, and then still in the first row, but now in the last column, I have minus 4 plus 40. Okay. Now I'm done with the first row. I have all 3 entries of the first row, so I need to move on to the second. So I'm going to use the second row, but then all 3 columns, one at a time. And that's going to give me 3 minus 3, 12 plus 1, and minus 6 minus 5. So pulling all of that together, the end result is going to be 26, 0, 36, 0, 13, minus 11. So this is the result for A times B. Okay, so now looking at B times A, I know from before that there's a chance, or that this matrix is probably going to look different than A times B. But in fact, it turns out in this case, I can't even do the multiplication. So let's see why. This matrix has 2 rows. The first matrix here has 2 rows, but 3 columns, so it's a 2 by 3 matrix. The second matrix is 2 by 2. So I check the 2 middle numbers, and I see that they don't match up, so I cannot perform this multiplication. All I can say in this case is that the product is undefined. I actually can't calculate it. And I'll explain why in one moment. So to see why I cannot actually perform this calculation, well, let's see what would happen if we tried. So I would identify the rows in the first matrix and the columns in the second matrix. Then, if I wanted to multiply the first row with the first column, we'll notice that the first row has 1, 2, 3 entries, but the first column has 1, 2 entries. I could try multiplying the 1 and the 2, the 4 and the 3, but then the minus 2 has nothing to be multiplied by. And you can see here that the 3, this 3 is in fact the number of columns, or the number of entries in that first row, and this 2 is the number of entries in this column I was trying to use. Since they are not the same, I cannot actually do the multiplication. Okay, so let's do one more example and then in detail, and then I will show you the remaining parts of this example. I'll show you the work, and then you can verify it on your own. Okay, so in this case, I want to show you at least one more example, in this case using 3 by 3 matrices. So this is a 3 by 3 matrix that I'm multiplying by a 3 by 3 matrix. Of course, the middle 2 numbers match, which means I can do the multiplication, and the result here will be 3 by 3. Okay, so let's see what the answer turns out to be. Whoops. Oh, well, in fact, I have it right here. So, okay, so let me just show you the work for this product. Okay, just like before, I'm going to highlight the rows of the first matrix and the columns of the second matrix. So you should go through and do this on your own and check to see that you have the same answer that I got. But let me show you where some of the numbers come from. So let's say I wanted to calculate this entry, for instance. Notice that this is in the first row, but it's in the second column. So to calculate this, I would take the first row of the first matrix, but then I would use the second column of the second matrix. And then when I multiply these, I get 2 times 1, so I multiply the first entries to get the 2, plus 5 times 0, so that's where the 0 comes from, plus minus 2 times 2, so that's where the minus 4 comes from. Okay? So that's how I get that calculation. Now, just as another example, let's say I wanted, I don't know, how about this entry? This happens to be in the third row and in the third column. So I would I would multiply the third row of A with the third column of B. 0 times minus 3 gives me the 0, plus 4 times 5 gives me the 20, plus 1 times 0 gives me 0. Okay? So let me clear some of that clutter so that you can see the numbers clearly, and then I suggest that you do the rest of the calculations and make sure that you got the same answer that I got. In fact, on that note, once you get done with that, you might want to pause the video here and work out B times A, and then in 1 second I'll show you what the answer there turns out to be. Okay, so if we multiply B times A, we end up with this. So you can see the work here, and you can see the final answer. Hopefully that matches up with what you got. If not, look through it carefully. Let me know if you can't find your mistakes. Okay, so part D doesn't contain anything new. This is still I'm multiplying two 3x3 matrices. So let me actually remove the work for just a second. So if you want some more practice doing this, I suggest you work through these on your own, and then when you're done, come back and then look at what the answers are. And so the answers with the work are as follows. And these are calculated exactly the same way as the examples in part C. Okay, so let's go on, and I'm actually going to work out two more quick examples, well, parts E and F, and then we'll be done with this video and done with this section. So in part E, I have a 3x3 matrix, and I want to multiply it by a 3x1 matrix. 3x1. Okay, so because the middle two numbers match, I can do the multiplication, and the result here is going to be a 3x1 matrix. So it's only going to have one column. So to calculate the answer, I need to identify the rows of the first matrix and the columns of the second matrix, just like in every example up to this point. So calculating the first entry, I need to multiply the first row and the first column. So that's 2 times 5 plus 3 times 3 plus minus 2 times minus 2. Then I move down to the second row, second column. Minus 1 times 5 plus 2 times 3 plus 3 times minus 2. Okay, now last row, and then the first column, or really the only column. 3 times 5 plus 0 plus minus 2 times minus 2. And then collecting all of those together and doing the final calculations, I'm going to get 23 minus 5, 19. Okay. Now if I try to do B times A, this is a 3x1 matrix times a 3x3 matrix. The middle numbers do not match up, so I cannot do the multiplication here. This product is undefined. Okay, so let's go on and do part F. In part F, we have a row and a column. Now, we already know how to multiply a row and a column. In fact, we've been doing it all throughout this example. But notice very quickly that if I apply the rule to see if I can do the multiplication, what I see is I have a 1x2 matrix and a 2x1 matrix. The two middle numbers match, and the result is a 1x1 matrix, which you can think of a 1x1 matrix as a number. And in fact, we've seen before that if I multiply these two, that's exactly what I get, is a single number. So I only have one row and one column, So multiplying those, I get 2 times minus 5, which is negative 10, plus 12, so that turns out to be positive 2. And I can think of that as a matrix, but it's kind of a silly matrix since it only has one entry. So instead, I'm actually just going to write it as an individual number. Okay, so that was really nothing new. We did several problems like that in example 3. But now let's see what happens if I do the multiplication in the other order. Instead of multiplying a row by a column, let's multiply a column by a row. Well, let's see if we can do the multiplication. We have 2 by 1 and 1 by 2. The middle numbers are both 1, so we can do the multiplication, and the product here is going to be a 2 by 2 matrix. So to see how this works out, I identify the rows of the first matrix, they're kind of silly because each row only has one entry, and then I identify the columns of the second matrix. So to get the first entry, I need to multiply the first row in the first column. So that's minus 5 times 2, negative 10. Then I move over to the first row, second column. Minus 5 times 4 is minus 20. Now I go down to the second row, which gives me 3 times 2, and then 3 times 4. Okay, so this is what I get when I multiply this column by that row, B times A. Okay, so that's it for this example. Let me know if you have any questions. Please feel free to come talk to me. This material can be a little bit tricky, and so yeah, don't be afraid to come ask for help.